Hello, my name is Akesh Sohan, and we will be discussing how a regular expression can be converted from NFA, non-deterministic finite autonoma, to the DFA, which is deterministic finite autonoma. And in this example, we're using A star, C, B star as our regular expression. So a regular expression, if we break it down into its components, it's A star, which is 0 or more occurrences of A. C, which is exactly 1C. And B star, which is 0 or more occurrences of B. And the whole idea of a regular expression is the language helps us search for patterns, and the state diagrams helps us visualize that flow of sequences. And in this case, the NFA is pictured here, and if we have our start state at 0, there's 2 epsilons coming out, and an epsilon is what distinguishes an NFA from a DFA, because an epsilon transition automatically occurs as like a pass-through transition. So if you go to state 0, it'll automatically pass to state 1 and state 2. And for breaking this down, this segment is where A star occurs. So if epsilon passes through to state 1, and you pass 1A, it will go to state 3, and then epsilon to state 2. Or you can have multiple A's, because this epsilon transition goes here, and then you can have multiple A's. And then it will then finally transition to state 2, where you will need that C in order to transition from state 2 to 4. It won't automatically happen. And then the final segment is this, where you can have a B, and then it'll epsilon to the acceptance state. Or you can have multiple B's. It goes epsilon to state 5, and then repeats to state 7, and then finally goes to state 6. Now, let's say you don't want any A's or any B's. You can have it goes 0, transitions through the epsilon. Now you must have at least one C. So if you have no A's, one C, no B's, it'll transition still to the acceptance state. So the first step in converting the NFA to DFA is to develop a yes-no chart for testing sequences. So in the case I just tested, let's say C, epsilon passes through to state 2, and then C allows you to transition, and then epsilon goes to the acceptance state. And you can have one or more than one A's, and then a C. So if you have epsilon goes here, 1A, then epsilon transition with the C, then pass through. Or you can have multiple A's, and then it'll still pass. Now you can have just a C in one or more B's if you would like. So epsilon passes here, and then the 1C passes from state 2 to 4, and then you can have one B, or you can have multiple B's. Now it does not work if you have only an A, because epsilon transition will be here and it will be stuck, because this is C. Or it can go here, you'll have the 1A pass, then the epsilon will still be stuck. If you just have a B, it won't even transition here, it will be stuck at transition 1 or 2, and you'll never be able to reach this segment. And if you, in the same case with AB and AAB, as long as you don't have a C, you will never be able to transition to the acceptance state because of this component. Now, first step after that is to get your NFA information into grid format. So to do this, you have the states listed for each row, and then you have your symbols for your regular expression across the top, A, B, and C, and epsilon not star, which means 0 or more epsilons. So now let me provide you an example of how to get these numbers. So if you're at state 0 and you input A, B, or C, there's no transitions with A, B, and C. So these are left empty. But there is an epsilon transition. At any state, you can remain at that state. So that's why there's 0 at state 0. And now there's epsilon transition from state 0 to 1 and 0 to 2. That's why you have 1 and 2. And let's say you're at state 1. There is an A simple transition that goes to state 3. And there is no epsilon transitions out, but you can always count the state staying at itself. And that's why there's 1. And same process is repeated for the other states. So now, once you have that grid of the NFA, you have to convert that to another chart that will help you develop that DFA, and that uses the information in the first chart. And to find out what the beginning row is, you have to look at the start state. So now if we look at the start state here, it's 0, but when going from a DFA, actually when going from an NFA to DFA, you have to get rid of the epsilon transitions. So you take those epsilon transitions and you start with state 1 and state 2, and that's where you start incorporating your sequence symbols. So that's why I started at 1 and 2. So now I will explain these headers right here. So if you're at state 1 or 2, you input an A, you will only be able to get to state 3 if you're at state 1. So now the epsilon star signifies that once you're at 3, you have to go to state 3 and look at that epsilon epsilon column. So that's where I got the 3, 1, and 2. So now if we go to state 1 and 2, there's no input. And if we go to C, there is input at state 4. So you go to state 4, go over to the epsilon column, and you get 4, 5, 6. And that's where I got this. So now, to get the rest of these states, you have to add a new state every time you get a new sequence. So after 1, 2, I got this, so then I put that here. And then I got 4, 5, 6, I put that here, and then you have to repeat the same process. So let's say I do 4, 5, 6. At state 4, 5, 6, I check for A, there's nothing. And there's nothing at C. But for 4, 5, 6, there's an input at B for state 5. So go to 7, go over to the epsilon column, that's 7, 5, and 6. Then I put that right here, and that's a new sequence, so I put that over here. Repeat the same process, and you will get 7, 5, 6 for an input B, and that is not new. So then this is where you know you've reached your acceptance state. Now I've highlighted both these states as acceptance because 5, 6, 7 is accepted, and since 5 and 6 are in this state, it's also accepted. So now this is our DFA diagram that's built off of this. You have 1, 2, 3, 4 states, 1, 2, 3, 4, 2 acceptance states, And then these are your inputs A, B, and C. So if you're at 1, 2, and you input an A, you will get to 3, 1, 2 right here. And let's say you're 1, 2, you input a C, you'll get to state 4, 5, 6. C, 4, 5, 6, and that's accepted. And now you can test that this works with your yes/no chart. So if you put in a C at your start state, you get to the accepted state. If you put in A, you get over here, and a C, you get over here. It's accepted. And if you have repeated A's, it loops here before you get to your final C, accepted. And also if you have like a C and a B, it goes a C over here, then B over here, which is your second accepted state. And you can have as many B's after as you'd like. Now a single A will be stuck here and not accepted, and a single B will not transition to either of these states and stay here and not accepted. And then an A and a B, the B will be stuck here because there's no transition. And this is how you convert your regular expression NFA to a DFA. Thank you.